Okay, this video is on sequences and recursion, and a sequence is just an ordered list of numbers or sometimes we say terms, an ordered list of numbers or terms set apart by commas. And you can see here in examples 1 and 2, we've got two ordered lists of numbers that are set apart by commas. And the ordered part is important because we want to be able to point to each particular term and say, like for example, this is the first term, this is the second term, this is the third term. And typically we do that by labeling them using a variable. I'll call this A with a subscript. So A sub 1, that indicates the first term. A sub 2, that's the second term. A sub 3, that's the third term, and so on. So in this sequence right here, I notice two things about the sequence. One is that the numbers are just kind of random. Right? There's no particular pattern to them. You know, this one goes up and this one goes up, and then from here to here it goes down and then it goes up again. They're just random numbers. Also, I notice that this sequence is finite. That is, there's only 1, 2, 3, 4, 5. It only has 5 numbers in it. All right. This sequence, on the other hand, it is not random. There's actually a pattern to the way the numbers go up. I notice they always go up by the same amount each time. They always go up by 3. So this one has a pattern. And it also, I notice, it's got these little 3 dots here. We call that an ellipsis, which means that this is an infinite sequence. It just keeps going on and on. All right? And the numbers, again, are ordered, A1, A2, and so on. All right. Now, this type of sequence right here is something that we call an arithmetic sequence. And an arithmetic sequence is just a sequence that has a constant difference. Sometimes we say a common difference between terms. So in this arithmetic sequence, our common difference would be 3. So let's take a look at this arithmetic sequence in a little bit more detail. I can see that my first term is 4. That is, A sub 1 equals 4. And my common difference, the difference between each one of my terms, is 3, or more specifically, positive 3. And we usually write that common difference using the letter D, so we would say D equals 3, or D equals plus 3. And I can see that my first term is 4, my second term is 7, my third term is 10, and in order to calculate any particular term in the sequence, all I need to know is the previous term. In other words, if you tell me a term in this sequence, then I can tell you the next term in the sequence just by adding on my common difference. That's called recursion. Anytime you can calculate the next value in a sequence just by knowing what the previous value is, that's called a recursive sequence. So we could express this sequence using what we call a recursive formula. And the recursive formula has 2 parts. First part is you have to say what the very first term is. So A sub 1, that's going to be your first term. And in this particular sequence we have right here, we would say A sub 1 equals 4. The second part of the recursive formula tells you how you get the next term. In other words, given any term in the sequence, what do I have to do to it to get the next term? Well, I know for this one I have to add 3, but in general, whatever my common difference is for an arithmetic sequence, I have to add that common difference. So I would say to get any term in the sequence, that is A sub n, where n is any term, I need the previous term, call that A sub n minus 1, and I have to add to it my common difference, which is D. So in this case, I would say a sub n equals a sub n minus 1 plus 3. And that would be the second piece of my recursive formula. Now there's also an additional piece that we add on to here, which is we want to note that n is always greater than or equal to 2. And the reason we note that is just because notice that if we let n be less than 2, well, we can't calculate a sub 1 using this little formula here, because a sub 1 is always just given to us. All right, so we include this little piece on here at the end that n has to be greater than or equal to 2. So far we've talked about these two ways of expressing our sequence, and our sequence is this one that we're looking at. We have sequence notation, which we just write down the sequence using commas. 10, 13, 16. We can use our recursive formula, where we say what a sub 1 is, and then we also say what a sub n is, a sub n minus 1 plus, in this case, 3, where n must be greater than or equal to 2. Now, there's also another way we can express this, which is using an explicit formula. It would be really nice if we had a formula where we didn't have to calculate, for example, every single term in order to find the next term. For example, what if I wanted to know what the 112th term of this sequence was? It'd be kind of a drag to have to calculate every single term all the way up to the 112th one if that was the only one I was interested in. I'd like to know a way where I could just calculate just that one term. That's called an explicit formula. So let's see if we can figure out how we would go about coming up with an explicit formula here. So I already know what a sub 1 is. If I wanted to come up with my second term, that is a sub 2, well, a sub 2, if I take a sub 1 and if I add on 3, my common difference, that's going to give me a sub 2. Well, how would I calculate my third term? A sub 3. Well, if I had a sub 3, again, starting with a sub 1, I add 3 to get the second term, add another 3 to get my third term, and that's how I would calculate the third term. What about the fourth term? Well, to get the fourth term, which is a sub 4, I start with my first term, I add 3 to get the second term, I add 3 again to get the third term, and I add 3 again to get the fourth term. And now I'm starting to see a pattern here as to how we calculate each succeeding term. I just keep adding additional 3's on, and it looks like, in this case, I have 3 3's, which is 1 less than 4. Here I have 2 3's, which is 1 less than 3. Here I have 1 3, which is 1 less than 2. If I do it one more time, my fifth term would be a sub 5, a sub 1. I add 3 to get the second term, add 3 to get the third term, add 3.
Mr. Davis, please report to your classroom. You have a visitor in your classroom. Again, Mr. Davis, please report to your classroom. Thank you.
I add another 3 to get the fourth term, and then finally I add another 3 to get the fifth term. So I see I add 4 3's to get to the fifth term. Well, my pattern, it's becoming pretty clear. If I want to get the nth term, then all I have to do is I start with my first term and I add 1 less than n. So n minus 1 times whatever my common difference is, which in this case is 3. So in general, to get the nth term, my explicit formula is a sub n equals a sub 1 plus n minus 1 times my common difference d. All right, let's take a look at this sequence, 5, 20, 80, 320. And this one seems to have a pattern as well, but I'm not adding the same thing to each term. It looks like what I'm doing is multiplying. if I take 5 and multiply times 4, that gives me 20. 20 times 4 is 80. 80 times 4 is 320. So in this sequence, I'm multiplying by a number. I'm not adding a number. Well, that's called a geometric sequence. A geometric sequence is a sequence that has a constant what we call a constant ratio between terms. So for this one, my first term is 5, again, which we write as a sub 1. And our common ratio in this case is 4, or more specifically, positive 4. And we usually write that with an r. So r equals positive 4. So for this sequence also, just like before, we can write it using sequence notation, we can write a recursive formula, and we can write an explicit formula. So let's look at what those are going to look like. My sequence notation, that's just written as a sequence. Recursive formula, again, I need to know two things. One, what's the very first term, which in this case it's 5. And I also need to know, how do I go about calculating a term from the previous term? Well, I know that in order to get any term, I just have to take the previous term and multiply it times 4. So a sub n is going to be a sub n minus 1 times 4, which is to say times my r value, my constant ratio. The explicit formula, okay, once again, it would be nice to have a way to come up with a particular term without having to calculate every single term up to that term. So let's see if we can come up with, if we can find a pattern just like we did before. So if I wanted to calculate my second term, a sub 2, for this sequence, I know it's going to be a sub 1 times 4. 5 times 4, that gives me my second term. If I want to calculate my third term, a sub 3, then that would be a sub 1. I'd multiply the first term times 4, that gives me my second term, and I multiply my second term times 4 to get my third term. To calculate my fourth term, a sub 1 times 4, that gives me my second term, times 4 again gives me my third term, times 4 again gives me my fourth term, and once again I'm starting to see this same pattern. The number of 4s, that is the number of constant ratios that I have to multiply my first term by, is always one less than the number of the term that I'm trying to calculate. So the nth term in my sequence is going to be a sub n is a sub, is going to be a sub 1 times 4 times 4 times 4, that's going to be 4 to the power of n minus 1. If n is 4, then n minus 1 is 3, so that's going to be 4 to the power of n minus 1. Or in general, you would say a sub n is a sub 1 times r, whatever your constant ratio is, to the power of n minus 1. And that's your explicit formula here.